Welcome to our video, Reimagining Transportation, Electric versus Public Transit Solutions. Today, we'll explore the crucial aspects of modern transportation methods as we compare electric vehicles and public transit systems. From environmental impacts to cost and scalability, we'll examine how these solutions can shape our city's future. Join us as we delve into the innovations and challenges that may influence the way we move in a rapidly changing world. 1. Environmental impact. Electric vehicles and public transit are both hailed for their potential to curb greenhouse gas emissions, a significant contributor to climate change. EVs stand out for their ability to produce zero tailpipe emissions, making them a cleaner alternative to gasoline-powered vehicles. This brings about a substantial reduction in air pollutants, particularly in urban areas where vehicle emissions are a major concern. Public transit, on the other hand, excels in reducing per capita emissions by efficiently transporting large numbers of people. A single bus or train can replace numerous individual car trips, thereby lowering overall emissions. In essence, both transportation modes present viable paths towards a cleaner environment, though their effectiveness can vary based on implementation and usage patterns. 2. Energy efficiency. When it comes to energy efficiency, public transit systems often have the upper hand, especially in high-density urban areas. Trains and buses are designed to move many passengers at once, which results in lower energy consumption per passenger mile compared to individual electric vehicles. This efficiency is particularly evident when public transit is operating at full capacity, maximizing resource use. In contrast, while EVs are more energy efficient than traditional vehicles, their efficiency can be affected by factors such as driving habits and battery performance. Therefore, in densely populated areas, public transit emerges as a more sustainable choice, contributing to reduced energy consumption on a larger scale. 3. Infrastructure requirements. The infrastructure needs for electric vehicles and public transit present distinct challenges and opportunities. EVs require a network of charging stations, including home chargers and public facilities, to support widespread adoption. Building this infrastructure is an ongoing process, with significant investment necessary to ensure accessibility and convenience for EV owners. Meanwhile, public transit systems demand substantial investment in rail lines, bus lanes, and maintenance facilities. These systems are complex and require continuous funding for operations and upgrades, but they can transform urban transportation landscapes when implemented effectively. The choice between these modes often hinges on the readiness and willingness of communities to invest in the necessary infrastructure. 4. Cost considerations play a crucial role in the adoption of both electric vehicles and public transit solutions. The initial purchase price of EVs is generally higher than that of traditional vehicles, largely due to the cost of batteries. However, this is often offset by lower operating and maintenance expenses over time. Public transit systems, meanwhile, require significant public funding and subsidies to remain viable. These costs are typically shared across the community, making public transit more economical for individual users. Nevertheless, the financial sustainability of public transit systems is a topic of ongoing debate, with funding often subject to political and economic pressures. 5. Scalability. Scalability is a key consideration when evaluating transportation solutions, particularly in urban settings. Public transit systems are inherently scalable, with the ability to expand and adapt to growing populations. By reducing the number of vehicles on the road, they can alleviate congestion and improve traffic flow. In contrast, while EVs can scale as more people adopt them, they may inadvertently contribute to congestion if not accompanied by robust traffic management strategies. Therefore, the scalability of these systems depends on the integration of thoughtful planning and policy measures that address urban mobility challenges. 6. Land use. Efficient land use is another advantage of public transit systems, promoting higher density, mixed-use development. By encouraging people to live and work in close proximity, public transit supports sustainable urban growth and reduces the need for extensive road infrastructure. In contrast, electric vehicles still require significant road space and parking facilities, which can limit land use efficiency. Cities that prioritize public transit often see more vibrant, walkable communities, where amenities are easily accessible. The choice between these transportation modes can significantly influence the planning and development of urban environments. 7. Range and accessibility. The range and accessibility of transportation options are vital for meeting the needs of diverse populations. Electric vehicles offer flexibility and range, allowing for personal travel beyond the confines of public transit routes. However, their effectiveness is contingent upon the availability of charging infrastructure, which can vary widely. Public transit provides a reliable alternative for daily commutes, especially in urban areas with comprehensive coverage. Yet, its accessibility depends on the frequency of service and the extent of the network. Balancing these factors is crucial for developing transportation systems that cater to the needs of all residents. 8. Technology advancement. Technological advancements are reshaping both electric vehicles and public transit systems, enhancing their efficiency and appeal. In the realm of EVs, improvements in battery technology are extending range and reducing charging times, making them more practical for everyday use. Public transit is also experiencing innovation, with electrification initiatives and the development of autonomous buses and smart infrastructure. These advancements hold the promise of more efficient and user-friendly transportation networks, capable of meeting the demands of modern urban life. As technology continues to evolve, both sectors are poised to benefit from new solutions that improve performance and sustainability. 9. Behavioral changes. Adopting new transportation modes often requires shifts in behavior and mindset. Public transit necessitates changes in commuter habits, with users needing to adapt to schedules and routes. Effective planning and reliable service are essential for encouraging widespread adoption. On the other hand, transitioning to electric vehicles involves alterations in driving and charging practices, yet aligns more closely with traditional car ownership models. Both modes require a commitment to change, supported by policies and incentives that facilitate the transition. Understanding and addressing these behavioral aspects is critical for fostering acceptance and integration of new transportation solutions. 10. Complementary solutions. Electric vehicles and public transit need not be seen as opposing forces. Rather, they can complement each other in creating sustainable transportation ecosystems. Integrated systems that combine EVs, public transit, bike sharing, and walking can enhance urban mobility, offering diverse options for different needs and preferences. Such systems can reduce reliance on single-occupancy vehicles, lowering emissions and improving air quality. By promoting a holistic approach to transportation planning, cities can develop networks that are resilient, efficient, and environmentally friendly. Embracing complementary solutions is key to addressing the multifaceted challenges of modern transportation.